It's like we're gonna do symmetric tree now, right?
Yep.
Okay.
All right. I never looked into the problem, so we can go look together right now.
Okay, sounds good.
All right.
Uh,
So are we ready?
yeah.
All right. All right. So given the root of a binary tree, check whether it's a mirror of itself, symmetric around the center. Okay. So basically, we have to just on a root tree, we have to know if left child is the same as right child.
Yeah. I think yeah. I think that's pretty much it. Okay. Well, we could just do a DFS on this and then like check to see like whether or not they're equal, right? And then if any of it is not, then that's when you return false. Otherwise, if you reach the end of the DFS, that's when you return true, right?
Yeah. But basically, what it means is wait. So it means that no, it's not that easy.
No?
Wait. Oh, wait. This is symmetric tree, right? So you can see
Yeah.
that here, it's three on the left and three on the right here.
Oh, right. It has to be
Yeah. So basically, you kind of have to either do like like two pointers.
uh-huh.
But like, I mean, like if you have, let's say you have like tree that goes more into deep. Like if you have
Yeah.
more children in here,
All right.
it's so much easier, right? It's an easy example, right?
Uh-huh.
Let's go through example number two, right? So we have two and three here and three and three, right? But you
Yeah.
can see that here it's like the children of two is three on the right, and here it's on the right the same. Why?
It would be false because like
Oh,
in order for it to be true, it would have to be like oh yeah, the mirror.
okay. So we have to check if it's symmetric. Okay, so one of the ways I'm thinking of doing that is you go you go um like is it in order when you go like super left, super down? Um
I think that would be like in it like so you want to traverse to the very left first. That would
okay,
be
very left.
in order traversal.
Okay, in order to both. Okay, so we go super left first, and or maybe we should go like bottom up, right? So but like how because
Hmm.
I just can't understand like it's very easy to try and solve this on this thing, but like what would be if you have like a bigger one? Like let's say it's two more levels in there. It's like
Uh-huh.
so much harder. I don't understand like what to start from. Um
Okay, wait. Let's first figure like define like what mirror of itself is. Basically, like the mirror is whether or not the left value and the right value are like they've switched places, right?
mhm.
So would it be possible to do a check?
Oh wait. So that means that basically every children should have swapped left and right.
Yeah.
So you have two pointers, you have to go left side and right side, and you have to check if those are swapped, right?
Yeah.
So you go first here, right? You check um you check two and two. You swap them. Are they wait, should they be equal?
Wait.
Okay, let's say are they equal? Yes they are. Okay, let's go next, right? You go to the two, you swap them and you check are they equal?
Uh-huh.
Oh no, wait.
Well, I think the tricky thing would be like for like let's say like for like the two and like the two and the two on the left and the right, you
Mm-hmm.
have to check whether or not those respective children are equal to each other.
Okay.
So, like in this case, you wouldn't
Because basically what you want to do is you want to swap the children and check if they are equal, right?
mhm.
So we can use the same way we did the previous problem. Like we go through the tree using two like left and right
Mm-hmm.
as two pointers? Or wait,
Yeah, yeah, yeah. Like.
so okay, let me think about it. So we go two pointers, right? And
Mm.
we swap the second tree. Let's say second tree, we swap the children, um and we just check check if they're equal, right?
Yeah.
Or better yet, we just don't need to swap the children. But like, so what I think to solve this problem is to go DFS
Uh huh.
and just compare values all the way, right?
Yeah.
Um, but the problem with that is that we basically have to swap first, right?
Mm-hmm.
So we swap first and then we compare the value.
Mm-hmm.
We can avoid swapping by just comparing right to left and left to right, so that way we won't swap. But like if we won't swap, then it means that the children um, of those trees would be incorrect, right? So basically, what we want to do is we want to swap the values so that when we compare the next values, we swap them again as well, right?
Mm.
So we just swap every time. That's what I think we could do.
Okay.
Um,
So basically like do a DFS and swap every time comparing like each one, right?
yeah.
Okay.
Um, well, okay. Let's try and do that, right? So let's try and do like root. So first, right? We check. We want to swap it, right? So we swap the. I will always be swapping. Oh, sorry.
Oh, it's all good.
I will always be swapping like right tree, right subtrees.
Mm.
So basically, if I go here, I will swap 3 and 4, and then whatever it will be under. So um so let's do DFS first, and then we have a current um as an argument, and then we'll do um here we need to swap them, right? So we
Yeah.
basically do current right equals current left, and then so now we swap them, and we want to compare, right? So we compare the. Um, are we guaranteed that we have the number of nodes in the tree is the range of one? Are we guaranteed? No, wait, we're not guaranteed that we have the symmetric tree, right? We either give true or false, right?
Yeah.
Whenever we encounter the value that is not the same in the left subtree, that
Mm.
means that we just return false. So whenever, for example, let's say we don't have 3 in here, right? We have only 4 as a child, right? But here we have 3 and 4, right? None is not the same as 3, so here we'll return just false. It's not symmetric, right?
Wait.
So
Wait. Can you repeat that again? So
yeah,
you're saying that like if like you swap like 4 and 3, right?
yeah. So basically, um, I swap them, right? Every time I go through DFS, I swap the values. But
Mm.
like the next step is to check if they are equal, right?
Uh huh.
If they're so that we would know if that's symmetric tree or not.
Uh huh.
But like let's say we don't have 3 here, right? So we swap the values. Here it will be none, and here it will be 4.
Oh, okay. Okay. Right. Okay. Yeah.
Then we'll compare 3 to none, right?
Yeah.
And none here is none. It's not 3, right? So
Yeah.
we will return false, right? So
Okay.
I was just like handling the edge case, like what if the trees are not the same, right? What if
Okay.
we
Yeah.
wouldn't have the noyer, right?
Yeah. Okay.
So
That's good. Yeah.
let's do temporary to current right, and then we reset the current right, and then current left. We say the temp. So this is how I swapped the tree. Um, and then now, uh, now that I swapped it, I have to compare them, right?
Yeah.
So, uh, current left. Okay, so if current, um, okay, if not current left or okay, if not current left and not current right. So here I check if they are um, both none, right?
Yeah.
So I return true. Basically, if they are both none, that means that they are both. So so I know that I just remember this how to do this. Like this is just handling the edge case. If we like, for example, if we go further, we have this tree. We go further. We have none, and here we also have none.
Yeah.
And if we have both none, we just return true. Now,
Uh-huh.
if some of them is not if some of them exists, right?
Uh-huh.
If current left or current right exists, we just else if current left well let's say else if uh, not current. Hmm. So how do we compare the values, right? So for
Mm-hmm.
example, now we checked if both are null, but like what if one of them is null, right?
Yeah.
What is in that case, right? So I'm thinking of like how should we check like um, if both of them are wait okay let me do that, right? Let me do first if we have both, right? So if
Mm-hmm.
we have both, if current left and current right, then we check current left value um, equals current right value.
Mm-hmm.
Okay, and if that's not true, if that's not um, if it's not true, then it means that we just return false, right?
Mm-hmm.
Uh, so we check if we have current right and current left, we just check them. If they're non, we just return false. But what if like I'm just used to like when I compare the trees, I'm just used to like compare like I just used to do like um, initialize this equal method, which
Uh-huh.
means that I will just be able to compare the objects, right?
Yeah.
Not the values, but the objects. And this object will handle like for me will handle like if something is non or something like that. But let me think. So here, right? If we have
Uh-huh.
both, we check both values. If they're not equal, then return false. Then if we don't have any values, we return true. But what if we have one of the values? Um, okay, else if, and then else. We now we have like one of the values.
Mm-hmm.
So I don't know how to handle that actually.
Mm-hmm.
Like let's think. How should I handle like so for example if I don't know like is it current left or current right? If I don't know which one of those is null, right? So how do I handle that?
Mm. Wait, so you're saying like you want to be able to handle like whether or not one of those values are null?
Yeah. But like I don't know how to do that.
Hmm.
Current left. So mm, so
Uh,
okay, let's just pretend we don't get this thing, and let's just try and like solve it like call the DFS, right?
uh-huh.
So here, right, we swap the values, we check return true or false, and now we run DFS on current dot left
Mm-hmm.
and DFS on current dot right. Is it right?
Hmm. Okay, so you're calling a DFS on the left and the right, and you're swapping it, and then afterwards you're checking to see like whether or not the current left. Okay, so if they're both not don't exist, you turn true. Otherwise, check to see if left and right they're both valid, and if they don't equal each other, then you turn false. Otherwise, you keep going. Okay.
Mm, yeah, but like the only case that I didn't solve is that what if we have one? What if we don't have one of those, right?
Yeah. Hmm.
Uh, Well, let's try and round this. Maybe that we don't have these cases. Okay. Um, Here
Okay.
we have this, right? One,
Uh-huh.
three, two, three, four, four, three, right? This is this case. Right?
Mm-hmm.
Let's try and see like how it goes, right? And how did it solve this one? Okay, this one it did solve, right?
Uh-huh.
Um, but the first one, so these are its two test cases, right? So let's check on first test case, right? So here, right, it will have, it will try and swap two and two. They will swap, and it will be 4, 3, 3, 4, right? They will swap. These two subtrees will swap, right?
Uh-huh.
So so then
Hmm.
um, these will not run if not current. Oh, this will run. So here it will check if current left value is equals current right value, and that equals. So what is the output? The output is false. So it equals. So it won't return false. It just goes next to the left. It went to the left.
Uh-huh.
Oh, okay. Here you can see that basically what it does is that it will go to the left here to the two, and then it will swap those values, and it will check if four compares to three, right? But that's not what we want. We want to
Mm-hmm.
check like four and three to this, right?
Mm-hmm.
So it's just more than that.
Hmm.
You have to pass. So basically, because what it does, it just goes into subtrees, swaps the subtrees, and in this case, it will compare 3 to 4, but we have to compare 3 and 4 to 4 and 3, right?
Uh-huh.
So it's like we have to somehow know like what is the value of these, right?
Mm-hmm.
I don't know. Okay, I'm stuck.
Okay. Do you want me to like kind of give you hints?
Yeah, let's try and do that.
Okay, so like your method of using the swap, it does make sense, but like you said, there's some like edge cases where that like may not necessarily work, or
Mm-hmm,
like might be like overly complex to implement for those
mm-hmm,
edge cases.
mm-hmm,
Another way of doing it is maybe like okay, like think about like a way we could do it without swapping.
mm-hmm,
So if so let's say we have like one um okay, let's say for the scenario we have like like 2, 3, and 4 in example
mm-hmm,
1.
mm-hmm.
um so in order to like check it, we can like figure out like a few cases, right? So if both don't exist, like let's say like 2 has no children, right? In that situation it would return true because it is symmetric, right?
Mm-hmm.
The next situation is if like what is it? Uh, yeah, if one of them doesn't exist, like let's say like for 2, 3, and 4, only 4 exists, right?
Mm-hmm.
That one should return false because it's no longer symmetric because
Mm-hmm.
it's like there's no value for it.
Oh,
Um,
right. So if there's even some of them does not exist, we just return false immediately.
yeah, like one
Oh,
false.
I see. I see. Yeah, but like the biggest problem with what I currently do is the way I do it, because basically what I do is the wrong way. Like I just basically go into the subtrees and
Mhm.
compare them, but like I have to compare one subtree to another subtree.
Yeah, I think like yeah, like that's the issue. Like you're comparing it like one like entire subtree with the other entire subtree.
Mm-hmm.
There's a way to do it where like it's only comparing it with like the left and the right.
Mm-hmm.
Well, um, well, I wait actually.
Because,
Uh,
like, for me, it seems like the best way to solve this right now would be breadth first search. Because, well, breadth first search goes through each level, right? It gathers the values from each level. So that way, it will do like that. So we can do like breadth first search of the first level, which will be 1, and breadth first search of the second level, which will be 2, and
mm,
then we'll do like breadth first search of a third level, which will be 3, 4, 4, 3. And then how we compare these values is basically we do like 3, 4, and then we just divide it by two and just like we'll have like here, right? We'll have on the third level, we'll have three, four, four, three, right?
Mm.
Three, four, four, three, and then we just split those arrays into into two arrays, which will be three, four, and four, three, and we'll just like compare them, right?
Uh.
Uh, to see if they're equal, right? We'll just do like we'll compare this from the start and this from the end, right? So it will
Uh.
be three, three, four, four, right? So this is how we would compare. So for example, if we would have like even lower levels, let's say we'll have like five, um, six, seven. It will be like five, six, seven, six, seven, five, six, something like that, right? So we'll
Mm.
just like do the same thing, right? So breadth first search for me is just easier. But let's just try to focus on doing depth first search as I already like started doing that.
Mm.
Just like how this problem, by the way, has a follow up. Could you solve it both recursively and iteratively?
Okay.
Uh, because breadth first search is being done iteratively, so this
Yeah.
is why it's easier. But we can do the depth first search recursively first, and then
You can also do DFS iteratively, with a stack, I
oh
think.
yeah, right, yeah. You just yeah, of course, yeah.
But then like I get what you mean though. Like
Yeah.
I'm pretty sure you can do it like using BFS as well.
Yeah.
Um
Okay, let's do that DFS. So let's think how we should compare the values on the level. So how would
maybe.
oh I see. Actually, you know what? Let me just comment it out and let me try to think. Right. So basically, to compare the values on the same level, we have to run DFS on current left and then DFS on current right. Um, right.
Yeah, correct.
And
Wait,
we
okay.
have to return something from DFS, right?
Maybe here's a suggestion. Instead of having to run like those two methods, like those two things separately, like
Mm-hmm.
creating two like method instances, why don't you pass in both of them as a single parameter into the DFS? Like, well, sorry. Why don't you pass both of them as parameters into the DFS method?
You
Like,
mean like left and right?
yeah.
Okay. Okay, that makes sense. Well, let's see. So I
Mm.
would rather prefer to have like one actually, like current.
But
But
then
actually,
like it would be harder to for them to reference each other, right?
no. What I think about is basically I want to I want to run the DFS and current left and current right, and I need to return something from DFS. So I will return like the values, right? So I will return. But will this work?
But the thing is, like, if you call DFS like separately with both the left and the right, then
Mm-hmm.
those like it'll run entirely for the left side first, and then it'll run entirely for the right side.
Mm-hmm.
Like, does that make sense? Or
Yeah, it does, Yeah, I see what you're saying. Yeah, I agree. So let's try and do return DFS on root left and then root right,
uh huh.
and then so now we have to first handle the condition where there's if if there's not left
Hmm.
or not right,
Yeah.
that means that we just return false. Because like if there's something missing, that means it's already not symmetrical, right?
Yeah. Correct.
So so they both have to uh, be set. So now we have a root of one, and we have two and two, and we have to so now we have to somehow like track
Hmm.
the um
Let's break it down into like scenarios. So you were able to figure out like it's like not left or not right, you return false. What happens if like they're both like none of them exist? If not left and not right.
this will handle it because like basically if they both don't exist, it will both go true and true. It will return false. So this
But
one should ensure that both of them exist, right?
but
Otherwise, it will always return false.
but if both don't exist,
Mm-hmm.
then wouldn't that be symmetrical? Because if you
Oh right, you're right. Okay, sorry about that.
No, no, no,
Yeah.
it makes sense. Yeah, like I get what you're saying from before. Yeah.
Yeah. Okay, so we definitely have to add if wait, if not left or not right. So
Mm-hmm.
let's do so this or is complete. So let's say um if not left and not right,
Uh huh.
we return true.
Yeah.
Otherwise, else if not left and not right,
Uh huh.
we return false. So
Okay.
now, because yeah, this edge case is handled, but let's. I'm thinking of how should we like flow next, right? So we have like left and right, right? So I guess we have to somehow do. Um,
Hmm.
oh, I see. Okay, okay,
There has
okay.
to be like what are you comparing now? Like
Yeah.
you don't have
So
to do any sort of swapping. What are you comparing?
yeah. So basically here, right? I will do DFS on left, left, and right, left, right, and then I will do DFS on left, right, um, right, and right, right. Does it make sense? But
So okay, like I okay. So let's break down those two statements. So you're calling it with the left's left and then the right's left. Is that what you want to be doing? Like calling like both the left and the left on there, or
let
like
me think. So
this is what gets a little bit confusing. So like take some time to think about this.
yeah, because if I will do that, it will be the same if I would be like having
Hmm.
just like one current. It will be just like this is the same flow if I would be doing just one pointer because it will just
Yeah.
go into
So how do we
both.
how do we modify it? Like
Yeah.
let's say like left left. What should you pass in? Wait go back go back. Like it's still like
So
just need to make a small tweak. Like for the left and the like left, you pass that in. What do you need to like pass in as the other one? Like think about what you're comparing it to. Like let's say like you're at like you're comparing like the number like
oh yeah, right. Oh, I see, right? So
uh-huh.
basically, um, so I compare left to right.
Yes, correct. Okay, good. Yeah,
Okay,
you're on the right track. You're on the right track. Yeah.
and then I compare right to left,
Hmm.
left.
And those
Yeah, oh, it's
and those need to both like those need to
yeah,
both like be valid in order for it to work, right?
yeah.
So
So we return DFS this and this, right?
uh-huh.
So let's see if it works, right? So this is edge cases that should work, right? But like, let's see. So one, two, like, this is the first, right? We go from root to left and root to right, right? So we are currently on this stage, and we executed. We don't return anything from it. We try and execute DFS, right? So we
Yeah.
execute DFS, left, left,
Uh-huh.
left, left, and we compare it to left, left, and we compare it to right, right.
Hmm.
But like if
So
oh yeah right oh yeah oh okay, I see so basically it will try and go so as far as it can, and in the end it should have
mhm.
return true, but like we should also compare if left value
Uh-huh.
does not equal the right value, right?
Yeah.
Because this is the main thing that we have to
Uh-huh.
return false, right?
Uh-huh.
And otherwise, if this solution, so for example, if everything is okay, right, it will go 1, 2, 3, 1, 2, 3, everything is okay, right? It
Yeah.
will reach the end, so this condition will work, and in the end, it will return true, right?
Uh-huh.
So basically, this DFS will go to the end, will try and go to the end, it will here reach out to the end, and it will return true. So if the true was here as well, we will return true for this one will return true, so then this will be true, right? And
Mhm.
the same applies to here, right? If everything works well here, which it will return true to here, and here it will return true to here, and
Mhm.
which means that this one will be true, and then
Mhm.
and condition will. So this one should work.
Yeah,
This,
try running it. Yeah,
okay.
great job.
Oh wait, this is not submit, right? It's not submit. Okay, let's do it.
Yo, good job, good job, good job. That was good. That was good.
Oh
Yeah.
no.
Dude, doesn't it feel so good?
Yeah, I mean, like, bro, although it's an easy problem, I almost did it on my own. Of course, you helped me with like a tip, but like
No, no,
I'm like,
you did the majority of the thinking. Like that was good. You worked through the like the original solution with swapping before realizing like certain aspects of it, like the edge cases, which needed to be handled by something else, right?
yeah,
Yeah.
yeah, yeah.
Yeah. You did pretty good overall. I like the way you explain things. Yeah. Like yeah, I like yeah, that's good. You did good. So
Thanks. We can do like next one with yourself, right? You can do like, well, I'm very stoked to have another problem. So like, if you have some more time, we can do the problem with yourself now. Like you will be solving, and I'm gonna be engineer.
oh, okay, okay, sure, yeah. Okay, sure.